Hi, today I'll be talking about vanillin, the compound behind the sweet, creamy aroma we associate with vanilla. Vanillin has the chemical formula CHH3 and it classified as a phenylic aldehyde. It features three key functional groups on a benzene ring, a hydroxyl OH, methoxy OCH3 and aldehyde CHO group. This contributes to both its scent and chemical reactivity. Naturally, vanillin is found in Vanilla planifolia beans. It produced during the curing process when enzyme break down a precursor called glucovanillin. By extracting it from natural source, it's expensive and slow. That's why most vanillin today is made synthetically, using compounds like glycol or lignin, a byproduct of the paper industry. These methods are cheaper and more efficient. Vanillin isn't just used for flavoring. It dissolves when in organic solvent, make it useful in perfume, medicine, bioplastic, and agrochemical. In short, vanillin is a key ingredient in both food and industrial chemistry, a small molecule with a big impact. Thank you.
Hi guys, Assalamualaikum. My name is Nisha Jani binti Teswa and I'm going to explain to you the physical and the chemical properties of vanillin. Vanillin, or other word is vanilla, has the appearance of white to pale yellow. The color is between the white and pale yellow that we usually or we commonly see in, for example, in ice cream. Vanilla ice cream usually comes in the white to pale yellow appearance. The second point is we're going to talk about the odor. The odor of vanilla is kind of sweet, and this odor was actually used in a lot of terms. For example, for like the ice cream smells like vanilla, even a perfume would smells like vanilla. So vanilla smells is actually quite likable amongst the people. Okay, first point, I'm going to talk about the melting point of the vanilla. Vanillin has a melting point about 81 to 83 degrees Celsius, and the solubility, vanillin is slightly soluble in water but very easily soluble in alcohol like ethanol, ether, and chloroform. So that's all for the physical properties. Let's move on to the chemical properties.
Hi guys, so now I'm going to explain to you the chemical properties of vanillin. So the first up is pKa. pKa is the one that is to measure the acidity in a certain solution. So in the vanillin, they have a 7.4, which conclude that they were weakly acidic because of their vanillin group inside the vanillin compound. So in vanillin, we have a hydrogen bond, which is they have a OH and the CHO group, which means in vanillin they have the alcohol and the aldehyde. And for stability, vanillin is actually stable under conditions, but they could oxidize in air. What does this mean? Actually, for a certain time, vanillin can actually oxidize, especially when they are exposed to moisture or to water. And lastly, the reactions of vanillin. We have 4 reactions I included in the slide, which is the oxidation, reduction, combustion, and substitution reactions. So that's all for chemical properties. Thank you.
Hi, my name is Nur Nabila Izzati binti Nazaruddin and my matric number 2023497954. Alright, let's start with the basic. What exactly is vanillin? Vanillin is the compound that gives vanilla its iconic aroma and flavor. It's classified as an aromatic aldehyde, meaning it has a benzene ring and a reactive carbonyl group. While it occurs naturally in vanilla beans, extracting it is time-consuming and expensive, which is why about 99% of the world's vanillin is produced synthetically today, using sources like glycol or lignin from wood. What's amazing is that this single compound, with just one aromatic ring, powers a global industry. From ice cream to body lotion, its reach is huge.
Alright, next, from taste to treatment, vanillin in our daily life. Vanillin's most well-known role is as a flavoring agent. It is used in everything, from cakes, cookies, and puddings to soft drinks and even protein powders. Its sweet and comforting flavors make it a favorite in the food industry, but its use goes far beyond taste. In pharmaceutical, vanillin helps mask the bitter taste of many oral medications. If I've ever taken a sweet-smelling syrups, chances are vanillin was in there. It is also a staple in the cosmetic and fragrance industry. It is warm, creamy scent blends well with floral and woody notes in perfumes, lotion, deodorants, and candles. Importantly, vanillin considered safe for regular human use, and it is approved by major food safety agencies like FDA and EFSA. Now, let's look at vanillin from a scientific perspective. In the chemical industry, vanillin is not just an end product, it is also a starting material or precursor from more complex molecules, especially in drug synthesis. In agriculture, it has been explored as a bio-based pesticide and plant growth stimulant. Some studies show it can actually protect crops without harming the environment. In biomedical research, vanillin is showing promising signs. It has been studied for its antioxidant properties, meaning it can help neutralize free radicals in the body. It also exhibits anti-inflammatory effect, which may help with conditions like arthritis or skin inflammation. Some research even points to neuroprotective potential, suggesting that vanillin might help protect brain cells against damage, which is exciting in the study of neurodegenerative disease. So while we love it for its flavor, scientists are investigating how vanillin might be used to heal. Why vanillin matters? Small molecule but give a big impact. In conclusion, vanillin is more than just a flavoring. It is a multifunctional compound that serves essential roles across industry, from the food we eat to the medicine we take and even the perfume we wear. Every year, the world produces over 80,000 tons of synthetic vanillin to meet growing global demand, and its potential keeps expanding. Scientists are constantly finding new ways to apply it, especially in healthcare and green chemistry. Vanillin reminds us that simple molecules can have enormous impact. So the next time you taste vanilla ice cream or light a scent candle, remember, you are experiencing the work of a powerful little compound named vanillin.
In this slide, we are looking at the oxidation reaction of vanillin. Vanillin, the compound responsible for the vanilla aroma, can be oxidized to form vanilla acid with the chemical formula CHM301. This reaction happens in the presence of oxidizing agents such as potassium permanganate KMnO4 or hydrogen peroxide H2O2. You can see here the chemical equation where vanillin reacts with KMnO4 under acidic condition to yield vanilla acid. Vanilla acid is widely used in various industries, especially as flavor agent in perfume and pharmaceutical formulation. Next, we move on to the acetylation of vanillin. In this reaction, vanillin reacts with acetic anhydride, producing a compound called acetylvanillin. This is a type of esterification reaction where the hydroxyl group on vanillin is replaced with an acetyl group. The resulting product, acetylvanillin, has a sweeter and more pleasant aroma compared to vanillin, making it popular as a flavor enhancer in food and fragrance industry.
Assalamualaikum, my name is Nur Shafika binti Yaakob and my ID metric is 2023625726. Reduction reaction. Vanillin can be reduced to form vanillin alcohol using reducing agent like sodium borohydride. Vanillin alcohol is used as a flavoring agent and fragrance enhancer, often used to modify or exchange a vanilla flavor. In conclusion, vanillin is a widely used compound known for its distinctive vanilla flavor and aroma, making it an essential ingredient in food, cosmetics, and pharmaceuticals. It is used primarily to enhance taste and fragrance, which is why it's found in products ranging from ice cream to perfumes. Vanillin can be obtained naturally from vanilla beans, although this method is costly and time-consuming. As a result, most vanillin today is produced synthetically from sources like lignin or guaiacol, making it more affordable and sustainable. In addition to its use as a flavoring agent, vanilla offers several important benefits. It has antioxidant property that helps protect cells from damage, and antimicrobial activity that contribute to food preservation and cosmetic stability. Vanilla is also being explored in medical research for its potential anti-inflammatory and health-promoting effects. Overall, vanilla is not just a flavor. It is scientifically valuable compound with diverse application and benefit, making it an important part of modern life.